Okay, welcome back to next session, fifth part of extending calculus of 11th standard. I'm sharing entire my screen to here. So get back to minimize and get back to the equation. So it is 9e. Okay. So what is the section name? Oh, it is not shared for you. I think okay, right. It is shared to them online. It is entire screen. Now it's been shared to you. Okay, so let's check my live session. It is also fine, working fine. And here I am coming. So what is the section name? Base E. It's a log base E. Simply log base E. It is log base 10 actually. Simply log, if you write, it is log base 10. In the calculators, you can see ln, which is natural log, which is a log base E. Okay. So I'm reading the first para. We have seen that E is approximately 2.7183 is the most natural base. In generally, we will take E only. That is the most natural base to use the exponential functions in the calculus. Work with the exponential function. While work with the exponential function, y equals to e power x is necessarily involves a work with the logarithmic functions because both are related. One is inverse application of e power x is log. So if you want to work with e power x, by default, you need to involve the logarithmic function log x base e because inverse function of y equals to e power x. Thus, the e is the most natural base to use the logarithm in calculus. So in this section, we introduce y is equals to log x base e and its graph. So now we are going to log x base e graph. Till now we have seen exponential. So now we will see the logarithm with base e. Okay, describing its relationship with the graph of y equals to e power x. So it is a composite inverse. So it is a reflection about x-axis. Okay, it is a reflection about x-axis. How if the graph of e power x is this, the graph of log x is this. This is the graph of log x base e. Okay, this is e power x. So it is there is a y equals to x. This is y is equals to x line, and this is the inverse of e power x is log x base e, and inverse of log x base e is again e power x. Okay, and transformations of the graph. So if you know the graph of e power x, you can know the graph of log x base e. If you know the graph of log x base e, you can know the graphs of if it is this is f of x, y is equals to f of x, then you can know the graph of y equals to f of x plus minus h, and even the graph of y is equals to k plus minus or plus minus k of f of x, or even y is equals to plus minus k plus minus f of plus minus h. So you can learn all these graphs. Okay, I want to rewrite this entire equation once again. If you know the e power x, or if you know the any basic function, so you can plot the graphs of y is equals to plus minus k plus minus f of x plus minus h. If you know the graph of f of x, so you can plot the graphs of all these 1 plus minus f of when f of x is equals to e power x log x basically. Okay, so the logarithmic function, because e is the natural base for logarithm, logarithm is base e or called natural logarithm. Okay, because the base is e, we call it as naturally. That's in general we will use it. So therefore, the log base e is called natural logarithm, and the function y is equals to log x base e is called the logarithmic function. To distinguish it from the other logarithmic functions such as log x base 2, log x base 10, and other bases. Okay. So in generally, what happens? Logarithmic function means log with base e only. Clear? Okay. So now log means log base e. Log means log base e only. Naturally, we have to consider when base is changed to specifically, we have to confirm that this is your base. Okay. Logarithm with base e are called natural logarithm. The logarithm function with base e is defined by y equals to log x base e is called the logarithmic function to distinguish it from all other logarithms. Y is equals to log x base a. Okay. So in generally, logarithm means log base e only is to be considered. In the calculators, you can see this is with the ln, natural logarithm, or logarithm natural base, which is ln means log base e. ln means log base e. Okay. So here are the graphs. I said that if you know the graph of y equals to e power x, you can know the graph of y equals to log x base e. I think you can see my previous graph. So this is log x base e. Okay. Oh, there are some intercepts are there, no problem. And here he plotted the graph with the help of table and all these values. Okay. So and there is a x-intercept, y-intercept gradients and all. We can see it is easy to understand. Next properties of logarithm function. So this is log x base c. The tangent at 1 is y equals to x minus 1. Okay, this is the tangent line, y is equals to x minus 1. Similarly, till now, whatever we did, what we did when y is equals to exponential function has been given. Exponential function has been given. Then we evaluated the functional values. Functional values. We evaluated the gradients of tangents. Gradient tangents. And once gradient of tangents is come, then it is normals also can be captured. And equations of tangents and normals. Equations of tangents and normals. Okay. And a graph, the basic transformed graphs. Transformed graphs. Transformed graphs. Okay. And asymptotes. We evaluated, we predicted the asymptotes, sometimes with the help of calculus, sometimes with the help of direct evaluation. Okay. And what is the domain of this function? The graph, what is 0 to on x-axis, because this black graph, it is a graph of log x. Okay. And this is defined when 0 to x, which is infinite. Okay. So your domain is 0 open, 0 is not touching, infinite. And the range is minus infinite to infinite, because downside it is going to minus infinite, upside it is going to plus infinite, only for the positive side of the x-axis only. Okay. So therefore, it is defined for x greater than 0, and the range as extends to 0 plus. What is mean by 0 plus? 0 plus means reaching. What is mean by 0 plus? What is x plus sign? From the right side, not positive. Okay. For example, 2 plus is also there. There is no positive. 0 to 2 is also positive. So plus stands reaching to here 2 power x, 2 plus reaching to from right side. From right side. Okay. 2 minus reaching to from left side. 0 plus reaching 0 from right side. As extends to 0 plus, it is you are going to minus infinite. As extends to infinite, you are going to plus infinite. It is 0 and this is 0 plus. Okay. Is it clear the points? Okay. So next, the curve has a gradient 1 and with x-intercept is 1 comma 0. And there are the intercepts. This is 1 comma 0 with x-axis intercept. And it is concave down, concave down, concave down. F double dash is always less than 0. You can think. Okay. For all. Okay, because y is equals to log x. You know, y is equals to log x base e. Do you know the derivative of log x is 1 upon x, and y double dash is equals to minus 1 upon x square. This is always negative. When y double dash is negative, you always concave down for all x. So therefore, concave down for all x greater than 0. Okay. But in the case of e power x derivative is e power x, e power x again e power. It is also positive. It is both are increasing because as x is greater than 0 only, x is defined only for the first. Okay. So increasing concave down, previously increasing concave up. The notation of logarithmic function. Now can you read this title? Three are different notations. They are not same. Okay. One is clearly mentioned who is your base E. Another one is base is not mentioned, but he written log in different style. No problem, but without mentioning base. And the third one is ln x. Who is ln x? Who is log x base U? You can see. In the calculus and mathematics, generally log x base U is the only logarithmic function that matters and is more often written simply as log x. The problem is that many calculators and even some mathematical softwares contradict this mathematics convention and use an engineering convention where log x means log x base 10. Can you read this para again? Mhm. For the engineering convenient purpose. Convention means according to their convenience. Okay. For the mathematics convenient, mathematicians convenience is log x means log x base u only, just as we discussed. But for the engineering people, they want it with log x base 10, so they captured this log x symbol for log x base 10. Okay. So now the log x base e is also written as ln x. Okay. Log x base e is also written as ln x. And where n stands the natural logarithm. I said number of times previously just now. So n stands the Neperian logarithms. Okay, the n also stands that Neperian logarithm in honor of Scottish mathematician John Napier. Okay, 1550 and 1617, who first developed the tables of logarithm for calculations, first published in 1614. Okay. The most sensible way to deal without confusion is never write log x without base, without a base. Can you read this point? Next point. Clearly it is been mentioned. Okay. So it is the most sensible way to write log x base e. Always writing log x. See, we are writing mathematics are a little bit lazy fellows. We don't want to mention the by default symbol notation. We have to understand that this is the case. Okay, it is just like a doing a makeup, okay, to an artist, writing each and everything neat and all. But do you know the problem with mathematicians is for the school and even for the college level of mathematics it is not an issue, but the post graduation level, the proofs of the theorems are very lengthy. Once you start the proof, you will write, so this is the things has been given, so this is the things we have to do, so what is our claim, so this is our claim. So after solving one page na, he will forget what he wants to prove. So repeatedly. So we are showing this. Let us show that. So right now our claim is so and so. So that kind of language he will use. Okay. So that's why by default symbol notation is most important. So here he using the condition lnx. Okay. So that's why the scientific calculation is all about engineering level of engineering calculation purpose. So in that we can see lnx means log base e or natural logarithm or Nappierian logarithms. Okay. Be careful of different convention of calculators where log means log x base 10 and the function labeled ln is used to find the logarithms is base e and the function e power x is used to usually located in the same button as ln because two functions are inverse of each other. So wherever you see ln in the same scientific calculator, there only you can see e power x because the same button. Can we see the Desmos? So this is the Desmos calculator. This is the Desmos. So here, where is ln? There is no ln. ABC, these are ABC. They are the function. So where it is? ln and e power x. Both are neighbors or no? Okay. And log means log base 10, not log base e. Most important observation to consider this kind of special considerations, conventions and all. Okay. And next, the notation for logarithmic function he confirmed. ln is approximating log x is the reverse of or inverse of the e power x. Log x is equal to approximate log x base 10, which is inverse of 10 power x. Okay. So, and never write without a base of logarithm. Never write logarithm without base. So, using calculator, you can find the significant figures. Log x log 10 base e means it is ln base 10, ln 10. ln, this is ln 10. In the calculator, you can see ln 10. And this is ln of 1 by 10. Okay. It is ln of 100. You can see with the calculator, you can find. Okay. How the answers of part 1 and 2. Because this is ln of 1 by 10, which is equals to ln of 10 power minus 1, which is minus of ln of 10. Minus of ln. Whatever the value you will get in the 1, its minus sign will be the second part. Okay. So that is the case. Combining logarithm and exponentials. So now this is the inverse function. This is the inverse under the composition. It is log ln x comma e power x or inverse to each other, inverse to each other under composition, under composition. Okay, under composition. So you can see the several base values. We should know the all properties of exponential. We should know that all properties of logarithms. Each and everything we have to apply. So this is log e power 10 base e. When 10 comes to the power function as it comes to the 10 log e base e, it goes to 10. And e power log 10 base e is also 10. Directly to complete 10. Complete 10. Transforming the, it's a transformation of logarithms graph. I said if you know any graph, basically y is equals to f of x. If you know the graph of this function, so you have a capability to plot y is equals to plus minus k plus minus f of x plus minus h. So you have to plot where h comma k are numbers. Okay. So if you know the graph of x, you have to know the graphs of y. See. So this is log minus x graph. What is the log x graph? Log x graph is this. Log of minus x is y reflection. Log x base e minus 2. What happens this graph? Can you comment about the B? Down. Two units of down. See, previously the graph is this actually. Okay, so normally the graph is this. Okay, it shifted 1 2 units to get down, and log of x plus 3. It's a plus 3. Plus 3 means left side, left 3 units. Here, x-axis, on the x-axis, it is moves left in 3 units. So it is 9e, 9e. So use your calculator to approximate the following, correct up to 4 decimal places. Where necessary, read note above. Remember that ln key, use ln key, use ln key. Can you read this note? Unfortunately, so mathematicians don't like this convention. Okay, so it is unfortunate. Okay, no problem. Engineering is also mathematics only. And my website name is STEM, STEMTeacher.Ca, Canada. So STEM means science, technology, engineering, mathematics. Okay. So technology, engineering, mathematics, and science, all four are same root trees. Okay. So use your calculator. Use ln. Don't use log. Okay. So you can do it. This is DIY. Okay, and you can use symbols. It is simply use the functions to label and demonstrate. Because it is a power function, it comes to the coefficient, the coefficient, and it is log base is 1, it is 2 into 1 is equals to 2. Similarly, you can do the simplification of all. This is also very simple. Logs applications, e power exponents applications, and you can simplify these values also, diy and diy and diy. So it's a development. So here onwards we have to go sketch the graph of y equals to e power log x base e, and then use the knowledge of transformation to follow the graph. You can do, you use the knowledge of transformations, graph transformations needed. So this is also DIY. You can understand. Where did we learn these kind of transformations? In quadratic equations. Do you know? In quadratic equation, there is a, what is the turning point? There is a turning point. Go to the turning point and shift your parabola to upward, downward, leftward, rightward, or accordingly you have to change those shifting of graphs. Okay, and copy and complete the tables of log x base e and log x minus of log x base e. So you have to simply evaluate the values and sketch the graph. And with the same, we sketch the graph. It is log x. This is your log x graph. This is your log x graph. What about minus log x? Plus becomes minus, minus becomes negative. Okay. Plus becomes minus, minus becomes plus. So it is minus log x. Minus log x means this is equals to log of 1 upon x graph. Okay. This is a graph of minus log x or log 1 upon x. And next, use the log values to simplify. It is e. Okay. And this is minus 1 by e. Simply using the properties of loss or log properties or loss of properties. And what is this? Log 3 base e plus log 2 base e. It is log 6 base e. Okay. And it is minus means it is a log 100 by 25 base e, which is equals to log 4 base e. Okay. Simply you can do. Okay. This is DIY. It is DIY. And next, 10th one. uh, Knowledge of transformations of graphs. You can get it, it is easily DIY. Use the log loss and change of basis, change of basis, change of base formula. Change of base formula, but he is not changing. Okay, change of base. Change of base means what happens here. Um, how can I say? How can I say change of base is nothing but the log a power m b power n as a base is equals to m by n log a base b. This is a little bit basic formula we have to use here in the problem number 11. You can do it. It is DIY. And use the knowledge of transformation. You have to plot these dots DIY. Okay. And this is the most important in higher education. See what happens in mathematics. Polynomials are very simplest form. In mathematics, the polynomials are best functions, very smooth functions. Easily we can analysis, easily we can do the differentiation, easily first derivative second derivative test, easily we can capture where its maximum is possible, where it is minimum is possible, where it is increasing rapidly or increasing slowly, decreasing rapidly or decreasing slowly, concave upward, concave downward, because very smooth functions. Okay, so that's why the mathematician, and they are differentiable functions, every differentiable continuous function, so you can do heart surgery. Okay, you can do heart surgery, but log x, e power x, they have restrictions. Why? When you write log x base a, so your x must be positive only, a must be positive, moreover a should not equals to 1. These kind of restrictions are there, but in the polynomials there is no such a restriction. So we need a polynomial representation of a function, and it is not possible to all functions. Only those are infinitely differentiable, infinitely continuous, infinite times of continuous functions of the derivatives. Then it can be converted into simply polynomial. Okay, easily, approximately, we can make a suitable polynomial, and in that process, this power series is most important. This power series is most important. According to here, power series involved means entire series sequences will come, everything will come. Okay, I will make a short of my explanation. So it is most important, that's why I'm telling, even I'm trying to make a short of this record. And see, this is a power series expansion, because the powers are increasing in a linear way. Here power is 1, here power is 2, power is 3, power is 4. There is a power series in mathematics only. So that is summation a n x minus a whole power n. This is a form of power series. N is equals to 1 tends to or 0 tends to infinite. Accordingly, we can consider 0 tends to. So this is called power series. Okay. And power series gives a lot of consequent comfortable results. So here what happens, when it is minus 1 less than x less than or equals to 1, the function log of 1 plus x base e may be approximated using a power series. So this series value, okay, and even the great Indian mathematician Ramanujan worked on this power series concept. There are quadratic forms, and there are several other research topics are there of Ramanujan, and he did a lot of work with these kind of notations. Okay, if you see in mathematics what happens, infinite is not captured easily. Okay, but with some loopholes of mathematics, we can capture infinite. That is the thing he did, Mr. Ramanujan. And do you know his? There is a great book. Is there the man who knows infinity? Okay, I think it's a movie. It's a movie. The man who knows infinity, because the diverging series says he made a convergence to some point. So that is a fixed point. Diverging means their sum is infinite, and he made that sum is equals to some finite number. So that's why he called as the man who knows it infinity. So all this important. I don't think so that this is required to you at for you at this level. And use this power series to approximate each of the following correct up to 4 decimals so and so. Okay. So what is log of 1 by 2? So we don't know this values directly, because log it is 2 on the 2 plus 1 is a 3 by 2 and base e. Of course, it is easily captured with log 3 base e minus log 2 base e, but it can be approximated with this power series. Okay. You have to sum. See, it is going to plus power is going to increasing and increasing and increasing. So the terms are going towards the infinity. They goes to near about to 0, because after a certain time we consider that remainder is 0. Okay. So with the help of this power series, we approximate values even without the calculator also. He said to do the calculator, use the calculator, we can. Okay. So they are very simple. I don't think so. It is not required to you. If it is interested, or no need, no need. Okay. But if you are interested, you can find up to see 1, 2, 3, 4 times. Submit this value, removing 1. It is 1 plus x. Let 1 plus x is equals to 5 by 4. Then your x value will be 1 by 4, and substitute x value here 1 by 4. See here, what is 1 by 4? In the first term, you will get 1 by 4. 1 by 4 means 0.25. What is x square? 0.25 whole square. What is 0.25 whole square? So I'm writing here 1 by 4 power. Okay. What is 1 by 4 value? It is 1 by 4 only. Yeah. What is 1 by 4? 0.25. What is 1 by 4 whole square? What is 1 by 4 whole cube? What is 1 by 4 power 4? 0.0039 power 5. It is for 10 power negative. It is minus 0. No, it is not minus 0.00097. It goes to almost 0. Reaches to 0 only. It reaches to 0. Okay. So that is the logic required. So here, try to get the values till up to 4 terms. Then after that, the rest is ignored because it is approximately equals to 0 only, rest entire term. So for all these values, make -1 and substitute x value here. Then you will get 1 plus x base a approximations. Okay. And then next, it is a 9f, exponential rates using the base e. Okay. So I'll continue this class in the next. Okay. The time is 2 p.m. Is at 29:25. Okay. So give me 1 minute. I want to close officially about my live stream. Okay. So this is about the fifth session of extending calculus of exponentials and logarithms. It is a quite good sessions, all these five till now. So you can understand what is the requirement to understand how to plot the graphs and asymptotes and even tangents of like equations of tangents, normals, where they are intersecting. If they are intersecting and making a triangle, you have to get the areas of triangles and all and all and all. Okay. So here I will stop now. We'll continue in the next session with the next section. Thank you to all for online.